Okay, I think I'm recording. Let's take a look at here at problem number 10. Now this section of problems, we're wanting to write inequalities and not equation, absolute value inequalities. Um, so we have some Coke bottle and we have a circumference, and we don't. If our bottle is too small, then we won't be able to put our desired amount of product, our desired amount of Coke. And if our circumference, if our bottle is too big, when customers look at it, it's going to look like there's less Coke in there, and they might think they're getting ripped off. We need our Coke bottle to be an ideal size because people are going to be able to look at that and kind of estimate the volume of that, and we don't want it to be underfilled or overfilled. Underfilled makes people mad. Overfilled, we're going to lose money. So let's let x be the the circumference of our Coke bottle, and we're in units of inches. Okay, so we ideally we want 6 inches, but we know that we can't have afford a bottle maker that will just be NASA accurate, that it'll be exactly 6 inches, because that might just be too much money to spend on that type of equipment. But we want to get reasonably close. Well, actually, I guess .05 does seem reasonably close to me, but if they wanted to be within .01 or .001, boy, that would be expensive equipment. Okay, so that's what it wants us to be within here. So it wants us to have this minimum value, this maximum value, and any Coke bottle that is produced that's within .05 inches um, of the 6 inches, and remember this is the circumference, is going to be okay. So if x is representing that true circumference, that measured circumference of the actual bottle, our target, our center is 6, and we have a middle portion of the number line shaded, so my absolute values is going to point towards my inequality is going to point towards the absolute value equation because I'm not out in the tails of the number line, I'm in the center. And because it says within the endpoints, I'm going to include those in my set, and I'm going to solve this absolute value inequality. So when it's pointing towards the absolute value, we can write it as a compound inequality, and we can write negative .05 is less than or equal to x minus 6 less than or equal to positive .05. And it's pretty easy now to solve for x by just adding 6 everywhere. So 6 minus .05 is 5.95, and 6 plus .05, and that's in inches. So as long as our Coke bottle is within 5.95 inches and 605, if it's in this range of values, including the endpoints, we're good to go. We're not going to reject it. If it's different than that, we're going to reject it. Let's take a look at the next one. An autopilot setting on the plane should keep the elevation within 5 feet of the actual elevation when set at 1,000. Okay, so you've got some airplane that's flying, at an altitude. It's at its cruising altitude. So this isn't when during takeoff or landing. So that's why the 5 feet. At first, somebody goes, "Man, I want my airplanes to be pretty accurate." Well, when you're 35,000, 20,000 feet above the ground, 5 feet is not. You're clearing the mountains if you're 5 feet above or 5 feet below if you're at that cruising altitude. So you're fine. So let's let x be our true altitude. True altitude or true elevate. It's saying elevation. And we're in feet. Okay. So our well, okay, actually it's 1,000. Okay, maybe I'm missing. Okay, it was my just guess when I just made up that number 20,000 or 30,000 feet or whatever I said. So if here's the ground and if you're flying 1,000 feet above the ground and you're on autopilot, you don't want that autopilot to accidentally nosedive and hit the ground. We want our autopilot to stay as close as it can, you know, even when there's wind gusts or other, any kind of turbulence. We want to be within 5 feet of that target. So let's write an inequality that represents that. If you're within 5 feet above or 5 feet below, we're saying that autopilot is working good enough. So if we let x, be the true, oh, we already wrote the true elevation. Oh, I'm not paying attention. I'm getting tired is what. So I've got x minus this ideal value, the center value of 1,000, and I need that to be within 5 feet. Okay, so I'm also listening to the Bob and Tom show you can't hear it, but on my headset, and Fred Klett is on there, and he's a comedian that's really funny. So it's distracting me a little bit. Okay, so this absolute value inequality, I can write it as a compound inequality, and now by adding 1,000 everywhere, I can solve this. So I've got 995. If I add 1,000 here, if I add 1,000 here, these cancel. And if I add 1,000 here, I get 1,005. So an autopilot setting on the plane should keep the elevation within 5 feet of the actual elevation when set at 1,000 feet. So the actual this is the actual elevation in feet. When our autopilot is such a good piece of equipment that it will keep the air. If you set it at 1,000 feet, it'll keep us between 995 and 1,005 feet, which seems accurate enough, sensitive enough, good enough. All right, let's see. I'll do this next one on another video.